Hello everyone and welcome once again to our channel. Today I'm going to show you how to rationalize the denominator. I know a lot of students are kind of scared whenever it comes to surds, but trust me, I'm going to make this enjoyable, interesting and less complicated. Without further ado, let's begin. Now, why is it important to rationalize the denominator of a fraction? It is simply because it is not proper to leave the denominator as an irrational number or to leave an irrational number at the denominator of a fraction. For example, this root of 5 here is an irrational number and it is not supposed to be here. Therefore, rationalizing the denominator simply seeks to remove this irrational number so that a rational number now goes to the denominator. How do we do this? Anyways, let's begin with solving these problems and I'll show you how to do this. Let's begin with number 1. Right here at number 1, we have 3 all over the square root of 5. How do we do this? Well, to remove this irrational number from the denominator of this fraction, we're simply going to multiply the top and the bottom by the same denominator. Let me show you what I mean. So this is now going to be multiplied by the square root of 5 all over the square root of 5. We have not changed anything yet. We're simply multiplying the left-hand side of this expression by 1 because root 5 over root 5 is equal to 1. They're dividing each other in this case. So we're basically multiplying this expression by 1. Now let's multiply it out. This is going to be equal to 3 times root 5 will give you 3 roots of 5. Okay, so in this form, it simply means that 3 is multiplying the root of 5. Therefore, 3 times root 5 will give you 3 root 5 all over. And down here, you have the root of 5 times the root of 5. If you multiply the two of them together, you are going to get the root of 5 all squared. Okay? It's just like when you have something like, let's say, a plus b multiplied by a plus b. Since they are the same, it's now going to be a plus b all squared. That's exactly what we did here. And then what happens next is that this is going to be equal to, we leave the numerator as it is. It's going to be 3 roots of 5 all over. So down here, if you square a square root, the squares are going to cancel out. This square cancels out with the next square, and what remains is now a 5. Okay, so 5 now remains, and this now becomes our final solution for this very problem. We have rationalized the this very fraction, which is 3 over root of 5. You've seen that the square root has gone out of the denominator. We now have a whole number there. Okay, so at this point, this becomes the solution. This is the simplest form. The idea is to remove this irrational number from the denominator, which we have done here. And whenever it is done, now you've won. You've answered the question. This is the simplest form. Let's go ahead and answer the second question here, which is more complicated because there are 2 terms or there are 2 square roots at the denominator. Let's see how we can answer this question. Hence, we're going to have our number 2. Let me copy down the question again. Our number 2 here says h all over the square root of x plus h minus the square root of x. Now, for this one that has 2 terms, we are going to multiply both the top and the bottom by the conjugate of the denominator. Well, you might be concerned, what is the conjugate of this denominator? Well, it's simply, since there are 2 terms, this is the first term, this is the second term, you change the sign that is in between. Okay, if it's a minus here, it becomes a plus when you multiply. If it's a plus down here, it becomes a minus when you multiply. That's the conjugate. You simply change the sign that is in between the terms. Please, A lot of students, they make this mistake of changing the signs inside the square root. Don't change this one here to a minus. Don't even do that. It is not right to change this one here to a minus. Only, let's suppose we have x plus h again inside the second square root. Don't even make the mistake of changing it, because that's going to be wrong. The conjugate is simply changing the sign in between the terms. So this one is now going to be a plus. Now let's do the multiplication and see how far we can go with this question. Remember, I said you always have to multiply by the conjugate. So this is now going to be times. On top, you have the square root of x plus h, and then it now becomes a plus the root of x. Okay? So don't change this one to a minus, please. You only change the sign in between. All over. So whatever you do to the numerator, you also do to the denominator. We have x plus h plus the square root of x. So you've seen that the numerator and the denominator are just the same. So if you divide them, you get a 1. They are both the same, just like you have 2 over 2. 2 divided by 2 is equal to 1. Since these ones are the same, they are just equal to 1. Hence, we have not changed anything yet. They are just the same. Okay, so I think I have to place this multiplication sign in a better position for proper comprehension to avoid confusion. Yeah, good. So this is just how it is. Now let's simplify this. Well, let's now multiply this h would multiply the first term. It would also multiply the second term. That's how it is. And in the same way, the x plus h would multiply the x plus h. The x plus h will also multiply the square root of x. And this one will multiply this and also multiply with this. That's how we're going to do this multiplication right now. Now let's do that. H times root of x plus h would give you h root of x plus h. Okay, so whenever you multiply, it has to be attached to the square root. Okay, that's simply multiplication. So this h here attached to the square root of x plus h simply means that the h is multiplying everything inside the square root. Now we're done with multiplying with the first one. Let's multiply the second by the h. H multiplies this one will give you h root of x. Okay, all over. Now let's multiply out the denominator. Here we've got the root of x plus h multiplied by the root of x plus h is going to give you the root of x plus h, okay, all squared. Remember that they are the same, okay? Just like when I showed you about this one, I showed this, that the square root of 5 times the square root of 5 will give you the square root of 5 all squared, since they are the same. Okay, now in the same way, this one is going to give you root of x plus h squared, since they are the same. Now let's multiply this again. Root of x plus h times root of x will give you plus the root of x multiplied by the square root of x plus h. Okay, they are multiplying, so this is the best way to represent the multiplication to avoid confusion. Now we're done multiplying the first term by everything on the right. Let's now go ahead and multiply the negative root of x by everything on the right as well. Hence, we shall obtain negative root of x times root of x plus h will give you negative square root of x, okay, multiplied by the square root of x plus h. All right. Now let's do for the last one, negative root of x multiplied by root of x. Okay, this and this will give you negative the square root of x all squared. Okay, since they are the same, we square them. Now let's work on the numerator. We will copy it down and say h square root of x plus h plus h square root of x. Okay, all over. What's going to be found at the denominator? Here we have two squares, right? This is a first square and this is a second square. If you square a square root, you simply cancel out the squares, and hence you're going to obtain when you cancel out this and this, you're left with x plus h. Okay? Now look at these two terms here. We have square root of x multiplied by square root of x plus h minus square root of x multiplied by x plus h, okay, or the root of x plus h. They are the same, okay? This and this are the same, and since they are the same, we can simply go ahead and cancel them out, okay? So one is a plus, one is a minus, this one is a plus, here you have a minus, just like you have minus x, okay, or let's say you have plus x minus x, okay? X minus x gives you a 0. In the same way, these two, when they cancel out, they equal 0. And here you have the square root and another square. They cancel out. You're left with minus x. Let's continue. Now, right here at the top, you've got h multiplied by x plus h plus h multiplied by the root of x. Okay? All over. What's now remaining at the denominator? Here we have x minus x will give you a 0. Okay? You can cancel out this equal to 0, and what remains is h. Now, if you look properly at this numerator, you can discover that if we factor out this h on top, we can cancel it with this one down here. So let me show you. Since the h appears on both sides, we can factorize it, okay, and then cancel them out. If you factor out the h from the first one, you're left with, you put your bracket this way, put your square root, you'll have x plus h left. And secondly, if you factor out the h from the second one here, you're left with the square root of x. That's the only thing that you're left with. So you're now left with the square root of x. All right, we just factored out a h. And then if you distribute this h again, you get the original expression back. If you do this, h times root of x plus h will give you this. And then h again times the root of x will give you this one. So we just factorize the h so that we can cancel out this h and simplify the expression. Now, since this h multiplies everything here, we can cancel them out. And when we cancel them out, our final solution now becomes the square root of x plus h plus the square root of x. And this becomes our final solution. Let me write it properly for better comprehension. So this now becomes plus the square root of x. And here is the simplest form of our surd. Now we've ended up rationalizing the denominator. Let's now solve the last problem, which is question 3. Question number 3 says, let me go and check it out again. So we've got root of 2 minus 1 over 1 plus root 2. So here we have the square root of 2 minus 1 all over 1 plus the square root of 2. Now, how do we solve this one right now? Like I said, it is improper to leave an irrational number at the denominator of a fraction. So our goal right now is to remove this. We have to remove this right now from this denominator. How do we do this? Okay, like I said, you always have to multiply by the conjugate of the denominator. Now, what's the conjugate of 1 plus root of 2? Remember, I said you have to change only the sign in between two terms. So we're going to change this sign right here. And now we multiply. It's not going to be a negative. Since it's a plus here, it's going to be a negative. So let's multiply the top and the bottom by the conjugate of the denominator. Here we've got 1 minus. Remember, it's a plus here, so it's not going to be a minus up here. Minus the square root of 2 all over 1 minus the square root of 2. Okay? Now, let's now multiply them out. It's going to be this 2 here. We multiply everything on the right. And this negative 1, we also multiply everything on the right. It's also going to be the same for the denominators. So watch me closely as I perform this beautiful operation. Right here, we have the square root of 2 multiplied by 1 will give you the square root of 2. Okay? Now, next up, the square root of 2 multiplied by negative root 2 will give you negative root 2 all squared. Okay, they are the same, so you just have to square them. Now, next up, negative 1 times 1 will give you negative 1, and then negative 1 times negative root 2. So minus times minus will give you a plus, and then 1 times root 2 will give you the square root of 2. It's just the same, no difference. All over. Now, let's multiply out the denominator. So 1 times 1 will give you a 1, and then 1 times negative root 2 will give you negative square root of 2. And next up, here we've got, remember that this number right here is not a negative, so that we don't make any mistake. This is a positive one. Okay, now root 2 times 1 will give you plus root of 2, and then root 2 times negative root 2 will give you negative the square root of 2, all squared, since they are the same. Okay, here you have a positive root 2, and here you have a negative root 2. They are the same, so you have to square the result when you multiply them out together. Now let's continue. Let me use the red pen. So let's work on the numerator. We have a root 2 up here, so this is not going to be the square root of 2 minus, so this square cancels out with this square, and we're left with 2, and then we have a minus 1 up here plus the square root of 2. Okay, so this minus 1 that we have here, it came from here. Okay, so this is going to be all over. Here we have a 1, we copy down the 1, minus root 2 plus root 2 is just like when you have x minus x is equal to what? 0. So minus root 2 plus root 2, they cancel out, they give you a 0. And now you copy down this negative sign here. And what do you have here left? This square root up here cancels out with this one, and then you're left with 2. Now let's simplify further. This is equal to, so the square root of 2, okay, plus the square root of 2, they are like terms. This one is a plus, this one is also a plus. So they will not give you, just like you have, for example, x plus x will give you 2x, okay? So in the same way, this is not going to give you root 2 plus root 2 will give you 2 root 2, okay? Just like x plus x will give you 2x. In this case, we're not multiplying, we're just adding them up together. So it becomes 2 root 2. And now we have negative 2, okay? Negative 1 will give you a negative 3. All over 1 minus 2 will give you a negative 1. Now let's continue. We have to remove this negative. Always remove the negative from the denominator, okay? And that makes it look perfect. I'm going to bring this 3 to the other side, and this 2 root 2 goes to the other side. So we have negative 3, okay, plus 2 root 2. You may be asking me, where is the plus coming from? Remember that this 2 root 2 is a positive value. So once the negative 3 goes to the other side, the plus comes out, and now becomes negative 3 plus 2 root 2 all over negative 1. So this is equal to, I'm going to split them up right now so that I can remove this negative sign from here. So we have, remember, this negative 1 is a common denominator for the two terms, the term on the this one here and this one right here. So this negative 1 is a common denominator for the two of them. Hence, I can split them up into 2 and write negative 3 all over negative 1. And then we've got, here we have plus 2 root of 2 all over negative 1. So I'm going to split them up so that I can simplify the expression. Now look at this here. The negative on top and negative at the bottom, they cancel out. So negative divided by negative will give you a plus. This now becomes a 3 all over 1. Okay. Now positive divided by negative will give you a negative 2 root of 2 all over 1. Okay. So this is now a negative. Okay, this negative has gone up here because a plus divided by a minus will give you a negative. So let's simplify. This is equal to 3 divided by 1 will give you a 3. And then negative 2 root 2 divided by 1 will give you negative 2 root of 2. And this becomes our final solution. So thank you for watching to this very point. If you have any questions, concerns, please write it down in the comment section, and I'll be right there waiting for you. See you in the next video, and bye.